In this problem, I am going to look at the calculation of an average acceleration for an object given its velocity versus time graph. So here we're going to have this is a velocity versus time graph here, and this is some data that we collected for this object. This is in seconds, and this is the meters per second for the velocity. And these are just some data points that we've collected from the lab. So in this example, we want to find the average acceleration of the object. So how do you do that? So we want to find, I'll say AVG. So the solution. First part of the solution is to list the equation. So for the equation, the average acceleration is what we call the average AVG is equal to the change in velocity over the change in time. This triangle, you'll see a lot in science, means the change in. And what it specifically means is the final minus initial. So whenever you see the delta symbol, that means change in. I'll write it right here. The Greek symbol delta, which is the triangle, means the change in. It's an H there, change. So what it specifically means is the final minus the initial over the time final minus time initial. So this is what we're going to use to solve for the average acceleration. So in this data here, which I could model with a straight line, and I put the data points right on these dots here, but the data might be off the line or on the line. But in this case, what I'm going to do is I'm going to choose a time frame. So let's say I want to know the average acceleration from, let's say, 3 seconds to 6 seconds. What is the acceleration rate during this time? From here to here. Okay, so what I need to do is I need to determine what my initial and final times and velocities are at those points and do the calculation. And what you'll see what I'm doing here actually is I'm finding actually the slope of the line. It's the rise over the run. This right here is the change in velocity, delta V, and this right here is the change in time. So it's the rise over the run, or slope in math class. So step 2, list the variables. So we're going to have the average acceleration, which we don't know. So the box. We have V final. We have V initial. We have time final and time initial. So my final velocity, or when I say final, it's at the point I'm talking about here, it's 12, and my initial is 6. So I'm reading off the graph, 12 meters per second, 6 meters per second. And my times are 6 seconds for my final and 3 seconds here. So it's going to be 6 seconds and 3 seconds. So when I solve for my average acceleration, the average acceleration, AVG, is going to be 12 minus 6 over 6 minus 3, which is 6 over 3, which is 2 meters per second squared. So during this time frame, my average acceleration is 2 meters per second squared. And actually, because it's a straight line, the slope is the same everywhere. So the acceleration at any 2 points would be the same value of 2 meters per second squared. One last note, this meters per second squared issue, where does that come from? If you take a look at what units we're dividing by, and I'll do it right over here, let's write more space. The average acceleration, AVG, is the change in velocity over the change in time, which is a meter per second divided by a second. So I'm dividing fractions. If you want, I can say seconds over 1. So meters per second divided by seconds. So as you know from math class, when I divide fractions, I invert and multiply. So this is really a meter per second times a 1 over second. And that's where you get the meters per second squared from. So that's the meter per second squared. But what it really means is I gain, in this case, 2 meters per second every 1 second. And if you take a look here, that makes sense. In 1 second, I gain 2 meters per second. In 1 more second, I gain another 2 meters per second. In another second time frame, I gain 2 more meters per second. So the meters per second squared is a nice shortcut way that physicists write it, but what it means is how many meters per second I gain every second. And that's a simple calculation to determine or calculate average acceleration.